Okay, welcome back to the channel. Today we have on the bench a Sharp XM-1801N out of a Nintendo Red Tint. And this is monitor number 7 out of 7 for my buddy in Kansas City who brought me a lot of 7 monitors to get going for him. This is the last one, so we're going to try and get this one all fixed up because then that way we'll be 7 for 7. Okay, so this is designed to run on 100 volts, not 110, so I have to use my Nintendo power supply here, or more specifically my transformer. So we're putting out 100 volts DC, or AC, I'm sorry, 100 volts AC, then it converts it to DC on the board through the rectifiers and stuff. But anyway, so the problem with this is it does function and operate, but it has some collapse, and the owner capped it already, but it still has the collapse. I was told that the collapse was there before and after the cap kit, so I need to go through and do some testing on the caps and make sure that none of them were put in incorrectly or the wrong ratings and things like that. But that's outside of the scope for what we want to talk about right now. We'll get to that later. For now, let's show what's happening, but something very interesting is also occurring. There is no brightness control whatsoever. The sub brightness pot does not work, and the main brightness pot down here does not work. So let's turn it on. You can see what's happening. 1, 2, 3. Okay, comes on, and we can see here. I need to clean my lens. I'm sorry about that. I need to clean the lens. You can see it does work and operate, but let's go ahead and skip past the ROM check. Okay, now there you go. Let's get to a stagnant image. Let's go ahead and just go into the menu here for ease of use. I should just have the TPG hooked up, but I like using an actual board. So you can see it works and operates. It looks really good. No issues, but we have about, I don't know, 1.5 inches on the top and 1 inch or so on the bottom. Now if I adjust the vertical size here, which is this guy right there, watch what happens here. That's the wrong way. See how it folds over on itself? Really badly. So if we adjust this to a point where it needs to be roughly about there, it's completely folded over on itself down here. And if we exit out of the menu, you can see that, yeah, it's completely folded up and upside down on itself. So the issue now is that a capacitor issue or something else? Because I was told this was happening before the cap kit, and it happened after the cap kit. The cap kit did not fix it, right about there. The cap kit did not fix it. So, is it an issue of the wrong reading, or if it's something else? So we have an issue with the vertical fold over, and I was told also there's no sound being generated, which that'll be something I'll have to figure out how to set up a test rig to do. I have a Nintendo Red Tint down in the basement. However, it's been retrofitted to use an external amplifier because I changed the monitors out to be K7000s. So I can't use the Nintendo Red Tint in my basement to really test this, unfortunately. I'll have to figure out some kind of jury-rigging thing to set the audio up and maybe test it out. But we need to see what's going on with the vertical fold over. Then we'll figure out what's going on with the audio, and we need to figure out why there's absolutely no brightness control. You'll see here that if I go to the sub-brightness pot here, you can look and see it says sub bright right there. So if we adjust that, let's see, down, up, as I turn it, we get, oh, it came off there. Let's see, we get nothing, absolutely nothing. I'll put it back in the middle. If we go to the main brightness, which is this pot right here, you'll see there that it says bright right there. If I adjust that one, all the way left, all the way right, absolutely nothing. Now, if we switch the color inversion switch right there, you want to be very careful. There's a shield right here, and you will get zapped really badly if you touch that metal frame there. That's why this plastic is there. So be careful when you're doing this. But if you flip the inversion switch, I've got raster lines, and I cannot, adjusting the sub brightness or the main brightness does not adjust this at all. I have to actually turn the screen pot down, and I have to get to a point to where the raster lines are gone, and now you can't even see the screen. So something is very wrong. Why it doesn't affect the opposite way on the regular colors here, or non-inverted, I can't say, but I mean, yeah, so we have a job ahead of us here to try and figure out the brightness issue, the fold over issue, and the no audio. So let's get cracking and see what we can find. Well, I got the chassis off of the tube, and you can take this whole thing out. It's just one assembly. There's a couple of screws under here, there's a couple of screws on the face, and there's the 4 screws back here for the brackets for the arms for the frame of the tube, and this comes right off. You gotta disconnect the degauss coil, which goes here, and the yoke, which is back here, and that's it. The whole thing comes out as one assembly. It's very kind of nice, actually. But I think I may have found our problem already. So there has been, doing some quick inspection, I have noticed that there's been some rework on all of these pots here. If we zoom in, there's been rework on all of these pots have been reworked. And that cracking, that's factory. That's with that resistor and that crack, they break the trace and put a resistor across there to ground. That's factory, so that's not an issue. But all these have been messed with. Now, if we look at the numbers on these pots, they've all got a number here: 502, 101, 103, 503, 502, and 103. Now, I've got a parts chassis over here. It's an 1801, just like the one we're working on. And if we look at this, we've got, let's do some contrast and compare if we can here. Can I get them both in frame? Probably not. Let's zoom out a bit. Okay, let's see if we can show this. All right, so we got a 502 and a 502, and we have a 103 and a 101. 103, 103. Let's see, that's at a 503 and a 503 and a 502 and a 502 and a 101 and a 103. So it looks like this is supposed to be a 103, and that's supposed to be a 103, and that's supposed to be a 101, and that's supposed to be a 103. So the 103 and the 101 are swapped, and 103 just happens to be the vertical size, and 101 happens to be the sound. So I don't think having the wrong rating would keep the sound from not working at all, but it would definitely affect our vertical size. So that was kind of a roundabout. I don't even know if I even could show that properly. Maybe we can try it again here. I don't even know if that worked because I couldn't look through the viewfinder and this at the same time. It's going to be difficult. Maybe we can, I can't get enough light on. I wonder if I can put some ancillary light, shed some light on this situation. Okay, so you can see that we've got a 502, a 502, so 502, 502. So we got, yeah, a 103, and then it goes to a 101, 103, 101, and then 103, 103, 503, 503, 502, 502, and then 101 and 103. So these two pots are backwards. So let's flip those around to put them in the right spot to where they're supposed to be. And I don't know if that'll fix our vertical size issue, but we can start with that. And I'm gonna turn my fan on here. We'll start there. This is sitting on my soldering iron stuff. So, okay, let's pull out this vertical size pot. Now, I don't know why somebody would have done that, and I don't even know if that's the cause of our vertical size issue, but if it's not even in the right realm of rating, that could definitely cause it. And if that's all it is, that'd be great. But I want to mess with our brightness issue as well, so we don't have to go back and forth taking the chassis on and off the tube. Is that going to be enough to get that out of there? Yep. Okay, so that needs to go in the sound location, and this one needs to go back in the vertical size location. everything else matched up, so it should be fine. Now, unfortunately, there's no schematic for this chassis. I did some research, and you know, they have the Sharp XM-1801 and the Sharp XM-2001 are basically identical, and everything that I could find when it comes to research is all saying the same thing. They're identical except for the size of the tube. They're identical except for the size of the tube, but I don't think that they are, because I've already seen some inconsistencies between this chassis and the 2001, but I can't say for sure, so we'll find out. But the point I'm trying to make here is that I can't find a dedicated diagram or schematic for just the 1801. So I've had some experience with this and the 2001, and they're, for the most part, they're right, but I don't think that they're actually identical. Maybe they are, I don't know, but it's just me. All right, so we got those swapped back. All right, so now I kind of did some probing around off camera before I found these pots being backwards, and if we follow the circuit for the brightness pot, there's 3 points here. There's this point. The actual potentiometer is across here. You can see the little resistor mark there. That's the actual potentiometer output. But from this point here for R95, it runs through some connectors, and it ends up going, these yellow wires here are the brightness pot. And they run right to this point right there, which translates to these 2 pins right... I lost it back upside down right here. So these 2 pins right here, they're inside of a little box with a J next to it. So you'll see here, if I actually go to this point here where it says R495, and we're on continuity mode, and we touch pin 1 or 2? 2, okay, so 2 ohms. You have to believe me, it's 2 ohms. So that goes to this point here on pin 2 of this 2-pin connector. Now the other side here, for the other part of the pot, goes right here to pin 1, and that's 1 ohm. So our brightness pot runs right to these 2 pins, and in corresponding here, this runs over to our sub brightness. Can you see this here? Okay, so this first pot right here is vertical linearity. The second pot here is our sub brightness. So we go to these same 2 pins, pin 1, 1 ohm, and then we go to the next one, pin 2. Okay, so these are a different ground here, but these are different points that run around somewhere else. But the point here is that our sub brightness pot and our main brightness pot are tied together onto pin 1 of that jumper, or not jumper, this J point here. So now, if we follow that around, let's zoom in, see if we can show this. So if we follow this around this way, it goes through J13, across to this side, and then it runs up this way around here across this jumper, J51, and then it runs down through the collector of Q409. No, it doesn't. It runs, okay, I'm sorry. It runs across J51, and it does go to the collector of Q409, but it also continues over here on this pad across R348, and then goes to this, over this way, across here to the base of Q408. Is that right? How did I... No, I'm lost. I traced this out earlier, and I ended up over here at ZD401, Zener dial 401. Now, how did I get there? I don't want to tell you wrong. It goes across J13, up this way, to J51, over to J51, and then it goes across, okay, yeah, R93. I went to the wrong point. So across R93 to the ground here, which goes around over here to ZD401. And if we check ZD401, it's negative on the ground side with the cathode line, positive on the anode side, and we get 65 ohms, 66 ohms. Now we get 1 ohm. There, I'll show you here. This is being done rather haphazardly. So like I say, I went through and did some preliminary troubleshooting off camera, so I don't have an hour-and-a-half long video. And I found this shorted Zener diode. So again, this runs across through here, up through the ground, across R38. I'm sorry, R493. Yeah, that's right, R493. And it comes around here to Zener diode. That goes to the anode of the Zener diode. So if we go to ZD401, 4 ohms. I had a bad connection on the leads earlier. Look at that, 4.3 ohms. And that diode is not supposed to be 4 ohms. If we grab this parts chassis here and we do the same thing, and we go to Zener diode 401 and we measure it on this chassis, we get, come on, the proper voltage drop, 0.4 voltage drop. We can round up to 0.5. Now again, if we go back to this other one, we check it again, we get 1 ohm. So we've got either a shorted Zener diode or something else that's causing it to reach shorted. We'll have to take it out of the circuit, but I kind of stumbled around there. My apologies. And let's see if we can trace this out properly this time. I just want to show it here. Okay, so we know that these 2 pins are for our brightness. It comes through here and goes across J13, which runs up here across to J51, which then goes up here across arc 493 and through this ground plane up over here to this lead of ZD401. That's how I got to that. So just following the circuit. Now going back to what I said about the diagram and the schematic, if you pull up the diagram for the Sharp XM-1801, ZD401 is not on the schematic anywhere. And if you look at the parts listing, it talks about ZD402, and ZD402 is part of the X-ray circuit. So there is no ZD401 on the 1801. I'm sorry, no, the 2001. Man, I am flustered tonight. The 2001 schematic does not depict ZD401 at all in any way, shape, or form. So that is a difference to the 2001 schematic, because it's not that this Zener diode. Wait a minute. There's a resistor in that spot. What the heck? Oh, there's a resistor in that spot on this one too. Well, that runs off to the neck board. Now wait just one darn minute here. Is that gonna read shorted if I unplug this? Because that runs directly to this wire. That's what that wire was, V1. Now, do we have a neckboard problem? I did not notice that. I found the short across those 2 pads and assumed that there was a diode on the top side. I didn't even look until just now. What happens if we check it now with that wire disconnected from the neckboard? Look at that. Well, what do you know? We've got a neckboard problem. You can't see it, sorry. But look at that. Now if we hook that wire back up to the neckboard, it goes right here. Does our short come back? It does not. Can somebody explain to me what's going on there? Why? What does that? I didn't do anything. This transistor was kind of bent around. I didn't notice it touching the legs, but it was kind of bent around. I bent it back straight. But that runs to the red drive pot, and that runs to all these resistors. Let's go straight down. Huh. Was it possible that this was twisted around and touching? I don't think so, because it was twisted around, but I didn't see it touching anything. I twisted it back. But you clearly saw that we had 0 ohms across here, and now we're reading correctly. Interesting. Did that just needed to be reseated? I don't know, now I'm kind of mystified. Well, you know what? I think what I want to do is, now that we've got that tackled, I want to see if possibly or maybe there's any difference. So we've got those pots swapped around. We got the pots swapped around. We've gotten rid of our short across ZD401. Man, this whole thing here has been one big amateur channel highlight here. Given the fact that this had the same issue before and after the cap kit, I'm tempted to think that our vertical problem was just the pots in the wrong spot. I think they may have swapped them trying to troubleshoot the audio issue. But the brightness issue, why did we have a short across what I thought was a Zener dial, but actually it looks like it's a resistor? That could be why the schematic doesn't show it, because it's actually in actuality a resistor. I need to take another look at it. But yeah, how come we had a short? All I did was remove this and hook it back up, and now the short's gone. Like I say, I did twist on this transistor a bit, but having this transistor shorted that's gonna short out and give us all of one color. If this transistor was actually touching the other legs and shorting out, we'd have all of one color. I don't know what color that is. It could be red, green, or blue, but we would have had all green, all red, or all blue. Now, you know, that maybe that's only in play during the inversion mode. I don't know, because we had the inversion mode with the horizontal lines, but I don't know. Let's hook it back up and see what it's doing now because we have different readings now. Swapping the pots and getting rid of our short. Maybe it'll magically work now. I don't know. Let's see. Well, it didn't work. It's still doing the same thing that it was doing. I actually took the neck board off of the donor chassis over here and swapped it with this one. It didn't make any difference either. So I'm going to put the other neck board, the original neck board, back on here. But in the meantime, I think I found the problem. So I went through the schematic, and looking at the schematic, the screen voltage actually comes off the flyback, and it goes through R602. Oh, wrong way. It goes through R602, comes off of pin 6, out of pin 6, across R602, across D601, and out through the rest of the circuit. Now, if we look at R602 on the donor chassis, well, I call it a donor chassis, but on the one that we're, you know, testing on, let's go to ohms and back out so we can get this in frame here. So R602 is this guy right here, and if we measure this in circuit, we get 10 ohms, give or take. So we'll set this one aside, and we'll grab 602 off of this one and measure it. And 602 on this chassis reads nothing. Well, I take that back. 1.3 megohm. And climbing. So we have an open R602, and that would definitely cause issues. Now, I don't know why it's not affecting the non-inverted side. This would explain why when we go to inverted, we get the raster lines, and the raster lines are present at no matter what brightness setting we choose. I don't know why it's not doing that on the non-inverted side. It should do the exact same thing. But R602 is open, and that's the cause of our raster lines always being there on the inverted side of things. So we have to remove R602, and to do that, we have to kind of take apart this flyback cage here. Can I get away with just raising it up here? And I gotta pull this little plunger here. Pop this out. So basically what's going on here is that if I started thinking, okay, if it's not the neck board, what is driving the raster lines to be maxed out and always present on the inverted side of the selector? It's almost like there's no screen voltage. There was no screen voltage adjustment. I could turn the screen pot down and I still had the raster lines. Or actually, technically, they're retrace lines. I refer to them as raster lines, but they're retrace lines. So I thought, well, let's go to the output of the flyback and just kind of trace it out. Well, sure enough, the first component it was faulty. R602 was open. So we'll steal it from the the parts chassis. And okay, there we go. Now, this thing is kind of sealed, so there's not really any way to take this apart without removing the wires from the neck board, but we shouldn't need to do that just to remove R602 here. Oh, it's dark. Yep. It is dark. And it's got a burn mark in it. Let's yank this out and we'll take a look at it. There it is. Burn mark and everything. And if we measure it again, we get nothing. So let's steal the one from this one. And I should say that our vertical size issue has been resolved by swapping that pot to the right location. We have fixed our vertical fold-over deflection problem. So that was, I had hypothesized that would have fixed it, and it did, but I still have the brightness still had no effect. So let's measure this one, and we get 11 ohms or so. Should be 10 ohms, but not in circuit, that's fine. Come on. Don't fight me on this. Let's see. There we go, 10 ohms. 10.6. So let's throw this in here and make sure it reaches 10 ohms in circuit and hook it back up and try for take number 3. Really? There we go. All right. Okay. Let's get this guy. Where's my tweezers? Just had them. There they are. Okay. That's in there. And we're soldered in. I'm going to reflow D601 while we're at it. And D601 does test good. Yep. So okay, with that done, let's go ahead and hook this back up and see what we get. I'm going to swap the neck board back. I'm going to leave this just kind of haphazardly like that. And then I'm going to swap the original neck board back on just so we can have it all back to the way it was originally. And then I'll hook it back up to the tube and see if it now works. Okay, so I have everything hooked back up, anode, neck, yoke, ground, power, video, and there's no remote board. They're all, down here. But I got the original neck board reinstalled. This is the one from this chassis, the parts chassis that I put on just to rule it out as a possibility of causing our issue. And after our 602 being replaced, did that fix our problem of our brightness control issue and the inversion being maxed out with the retrace lines? Let's find out. Here we go. 1, 2, 3. Okay, it comes right on. And I mentioned before I had already said that changing that pot out fixed our vertical size issue. So let's adjust vertical size here, and you can see that that is now resolved. There you go. So no more fold over, and we're going to put it right about there. And let's see if our brightness control now works. Which one is it? There it is. Hey, look at that. All the way down, all the way up. Let's put it down to about right there. Sub brightness. Okay, that's up, down, up, down. We'll put it right about there. Woohoo! It freaking works. So there we go. So we had, oh, I didn't test inversion. Let's go to inversion. Again, be very careful of this heatsink. You will get zapped. So flip the switch and yes, okay. Inverted, non-inverted. Fantastic. So this is going to be, again, a Nintendo Red Tent, easy for me to say. So we do have a little bit of lines. So let's turn this down ever so slightly. Right about there. Okay, perfect. Now we can turn our sub brightness up slightly. All right, fantastic. Flip the switch again, and boom. Actually, it needs to be roughly about, we'll put it right there. Outstanding, boys and girls. Look at that. Awesome. So now we just got to figure out our audio issue. See, I still got, what is going on here? Let's turn this back down a bit. Okay, there we go. Brightness up a little bit more. We'll go right there. Turn this back. Okay, that's good. All right. Sweetness. All right, so it's now fully operational, except for testing the audio. So we had a faulty, what did I do with it? R602. I don't know where I put it. I put it somewhere. But, okay, so we'll have to get this back together after we get the audio issue. So the audio has a connector here that plugs in right there. That is the input from the PCB. That's what this is. And it comes, this comes from the PCB, and it runs through here and gives the input to the chassis. And the onboard amplifier, which is this thing right there, and this whole circuitry right there, that IC right there is the amplifier, and the speaker output is right here. So I gotta see if I can jury rig some kind of connection here. I forgot to hook up the decals coil, but that's no big deal. It's right here. Yeah, I need to do some reflow and other stuff. I also need to take my, I gotta take my fiberglass pin and clean the header pins. The yoke connection, the header pins like to get very oxidized and they cause the yoke to burn up. So I'm going to clean up those with the fiberglass pin. I got to do some basic housekeeping, reflow, and all that stuff, which I'm not really going to show on the camera. You know, you get the idea on what it takes to do all that. I've shown it on many videos, but let's see if we can get this audio circuit working and come up with a solution for that. Okay, so I had to make a switch to WWF WrestleFest because my MK board doesn't have an audio board. So I had to switch to WrestleFest, which has, you know, audio amplification built into it. Here's the volume pot. So I have the JAMA speaker wires running to the input, which run over here to the chassis, which then I have set up here running to my bench speaker. And all you hear is this humming. And it does not change with the volume pot. If I... Oh, where'd my screwdriver go? I just had it in my hand. Here it is. If I adjust the volume, the sound pot, all the way down, all the way down. Come on, you stupid thing. All the way down, all the way up. I'll put it about halfway. Now, watch what happens when I turn up the audio here. It goes haywire. It affects the screen. That's with the audio pot on the board down. That's with it turned up, and it does nothing for the audio. So there's something wrong with the audio circuit that is affecting the rest of the monitor. So I think I'm going to change out the amplifier, or test the amplifier, because I've got the full audio circuit here on the parts board. So I'm going to start going through and seeing what I can figure out, because there has to be something going on. And it's possible, you know what? I know what it is. I know what it is. Somebody has the degauss coil hooked up to the amplifier connector. I say somebody, I did the same thing, but I plugged it in the way it originally was. Let's see what that does. Here we go, 1, 2, 3. Ah. If I adjust the volume, does that go down? It does. Down, up. All right, so let's start a game. Here we go. Turn up the volume on here. Hey! Well, what do you know? You got to hook the stuff up properly. I realized after looking at this where it says power or PWBF, I'd say probably power something or other. I realized, wait a minute, that's the connector for the audio. Well, there you go. So, not hooked up properly. So now we still have some interference here going on, but I think it's because we have dual amplification here. So I got amplification coming out of here, which is being amplified into the amplifier circuit. So I think this is a situation where, let me grab an MK4. We need to hook up a circuit that doesn't have, or we need to hook up a board that does not have onboard amplification. I don't think I have something. I have an MK4 board, but it's probably going to be the same situation with this because it has onboard audio amplification. Like the Nintendo games don't have onboard amplification, which is why they have it built into the monitor. But regardless, I think we're going to go ahead and call this a successful repair. I have no explanation as to why reseating the V connector there, or V1 connector, originally got the ZD401 reading or whatever to read properly. I have no explanation for why we were reading a short before, and after we removed and reseated that connector, it went to normal. I have no explanation for that. But the root cause of our problem ended up being a swapped audio and vertical size pot for the vertical foldover. And also the cause of our brightness inoperative control circuit was the Open R602, I think it was. I can't recall. I don't know what I set it somewhere, and I don't know in all this mess where I put it. But we know that was the fault, and then we had the audio was hooked up incorrectly for the power for the transformer. So I'm gonna call it good. So I gotta clean up all this stuff. I still gotta do my reflow and clean off the header pins for the yoke and things like that. But otherwise, yeah, it's good to go. So thanks for watching. Hopefully you learned something. Like, share, and subscribe. And I'm glad that I was able to get all 7 of these monitors working for my buddy up in Kansas City. I don't think I have anything on the horizon. I got all 7 of these done. I'm going to go on the hunt for... I want to make a video about the K4900, the 3 different versions of the K4900, along with their 3 yokes that are required for those 3 individual versions. I'm going to go out and try and find the correct... I'm missing one version. I'm going to try and find that version in the yoke, and I'm going to do a video here probably soon on... the specifications of requirements for all 3 of those individual K4900 setups. So stay tuned for that. Otherwise, thank you very much. Like, share, and subscribe, and we will see you next time.